Hello, beautiful people. Are you ready? Are you super excited? Okay, so what I wanted you to do, what you should have already done, is worked through these problems here. So if you haven't done that, stop the video, do that first. Okay, I want you to work in your groups, spend as much time as you need to try these problems, and then I'm going to go over them very quickly because you should have already worked them out together. Okay? So we're talking about special right triangles. Yes, get excited. Oh wait, before we begin, sorry, you should have already done this actually before your quiz, but if not, yay math! Yay math! Okay, great job. I'm so proud of you. Okay, so we're talking about special right triangles. You should have calculated the angles here to be 45, 45, and the 90 was given. So this special right triangle is called a 45, 45, 90 triangle. You could also call him, I don't know, Bob or something, whatever you want. But in the math world, we call it 45, 45, 90 because this angle here is 45 degrees and this is 45 degrees. How do we know that? Because this is an isosceles right triangle. Since it's isosceles, we know the base angles have to be congruent. So 1 and 2 are congruent to each other. Therefore, if I do 180 minus 90, and then divide 90 by 2, the only option is 45 and 45. So that's the name of this special right triangle. What makes it so special, though, is this pattern that you should have noticed whenever you calculated the length of the hypotenuse. I'm just going to do the first one with you, and then you'll notice the pattern, or you should have noticed the pattern with all the other ones. So what I wanted you to do is fill out each leg here was 4, and then calculate the hypotenuse. By the way, this is coming from up here, right? That triangle A is where you should have filled that chart in, right? And then B, you should have filled it in here, and so on, right? Okay. So I'm going to do A in this little space provided. Not a lot of room to work out the Pythagorean theorem, so I apologize. But each of the legs is 4, so we do 4 squared plus 4 squared, and we're trying to calculate C squared. So that's going to be 16 plus 16 equals 32 equals C squared, and square root both sides. Okay? If I'm going too fast, guess what? That's what the pause button's for. So 32 is going to break down into 16 and 2. 16 breaks down into 4 and 4. So we can really just stop there and take that pair of 4s out. Even though I could keep simplifying, it's unnecessary because I have a pair of 4s. And what's left is this little 2 who doesn't have a pair. So that means the hypotenuse is 4 square root of 2 in this 45, 45, 90 triangle. 4 square root of 2. So you should have filled that in the chart. And then when you take the hypotenuse and divide by the leg, the 4's cancels and you get the square root of 2. Okay? So that's what you should have done for A, B, C, and D. I'm just going to fill in the chart and what you should have gotten. You should have gotten 5 and 5 square root of 2. And this would also be square root of 2. C would have been 42 and then 42 square root of 2. And this would have been square root of 2. And so this last one would have been x square root of 2. And this would also be square root of 2. Okay? So why is that important? Well, we see this pattern, guys, right? You see for every leg, the hypotenuse is that leg and then multiplied by the square root of 2. So that's a really, 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 really important fact for you to know in all of your math classes starting now, okay? So not only should you learn this and memorize this for Miss Coffee's class, you need to keep memorizing it for your other math classes. Got it? I'm serious. Okay, the hypotenuse of an isosceles right triangle is the leg multiplied by square root of 2. This formula can also be written just as an equation. Hypotenuse equals the leg times square root of 2. Okay, so you'll see me write that a lot whenever we're trying to solve. Alright, so if you didn't already do number 5, let's do number 5 right now together. And then I have some other examples to kind of help you through these. Okay, so for number 5, you're given this leg here is 8. Since this is 45 degrees, the other leg also has to be 8, so you should have done that. And then, because my formula is the hypotenuse is equal to leg times the square root of 2, that means you're going to take the leg, which is 8, and multiply it by the square root of 2. That is the length of my hypotenuse, and we're done. What? That's crazy. So no Pythagorean theorem required. You can check your answer that way, but it's not required. I'm going to take a moment and skip over B and come back to that because that one is difficult and I need a lot more space to explain some things to you. Okay? Alright, let's do C together. So since this is my leg and I want to calculate the hypotenuse, which is here, okay, this is still a 45, 45, 90 triangle, okay? So in order to do that, again, formula is hypotenuse equals leg times square root of 2. So this looks a little different though. The leg is 3 square root of 5, and then I multiply that by, by the square root of 2. So guys, when I multiply, if you remember when we did that simplifying radicals packet, you multiply the numbers under the radical. That's 5 and 2, so that's going to be 10, and they stay under the radical. They still don't have any pairs to break out of jail. And the 3 is still left outside. So the hypotenuse here is 3 square root of 10, because I multiplied the leg by the square root of 2. Okay? Alright, so what I'm going to do now for B is get some more space so we can do that together. Oh, I meant to do this. Okay, here we go. So in order to solve for this, you're actually given the hypotenuse, and I don't know what the leg is. So if my formula is hypotenuse equals leg times the square root of 2, let's plug in what we do know. We do know that the hypotenuse is 12. We don't know what the leg is, so let's go ahead and call that x. Keep in mind that both of these legs are the same. So this is x square root of 2. So how would you go about solving for x? Probably isolate the variable by dividing both sides by the square root of 2. And that cancels out. Cool? Okay. So here's the problem. You might think, okay, so my answer is 12 divided by square root of 2. No, because some mathematician in the world decided that we are not allowed to have the square root, so no radicals, in the denominator. Denominators. No radicals in the bottom of the fraction. What? That's crazy. Well, how do we fix that? Okay. If you were my pre-AP, then we did that last page, simplifying radicals. We did rationalizing the denominator. Okay, actually we didn't go over it. I just asked you to try it out, and I said we'll do it later. So here's later. For your academic, this may be the first time you're seeing this, so pay close attention. Rationalizing the denominator, and you will have a few examples on your homework like this to help you practice, okay, because you need to know. Here's what, first of all, what it means is the goal is to get rid of the square roots in the denominator, okay? You should probably write this like in your notebook since your quiz is open note. So if I want to get rid of this square root of 2 in the bottom of this denominator, right? What I want to do is, the first step is going to be to multiply the top and bottom by the denominator. I hope you don't mind me abbreviating denominator right there. Okay, so we're going to multiply the bottom and the top by the square root of 2. Okay, which is totally allowed because this itself is just 1. That becomes 12 square root of 2 on the top. And on the bottom, here's what's going to happen. This is going to be square root of 4 because 2 times 2 is 4. But it's a square root of 4, which is in fact just 2. So on the bottom, you can see, oh look, I've gotten rid of the square root, right? Look, no radicals. So that's the whole point. And then I simplify by dividing this 12 and 2 to get 6 square root of 2. Okay? So that's a lot of work, right? If you go back to B, that's what I was trying to solve for. X, the leg, is 6 square root of 2. Both the legs are 6 square root of 2. Now you're probably like, Ms. Covey, no. There has to be an easier way. Well, in this case, you're right, there is. So here's a little trick when you have the square root in the denominator. I'll give you an example. If you have a number at the top and you have the square root of 2 at the bottom, your answer is going to be 9 square root of 2. Let me give you a different one. If it's 20 on the top and square root of 2 on the bottom, your answer will be 10 square root of 2. Do you see the pattern yet? One more. If you have an 8 on the top and the square root of 2 is in the bottom, guess what it is? 4 square root of 2. So what's the pattern here? You're going to take the number on the top, divide it by 2. And then you just stick this square root of 2 next to it. Boom, boom, boom. 20 divided by 2 is 10. Stick on that square root of 2. 8 divided by 2 is 4. Stick on that square root of 2. You want to try one on your own? Okay. Look, I'll give you a crazy one. 200 divided by the square root of 2. Guess what that's going to be? You guessed it, 100 square root of 2. And guess what? You can check it on the calculator. This gross decimal will give you the same thing as this gross decimal. They'll be the exact same gross decimal. Okay? Alright. So that's my little mini rationalizing lesson. You'll have a few questions on the homework like that, alright? But mostly your questions should be like A and C on this problem. Okay? Alright. So that concludes, B is 6 square root of 2, right? Notice how that's half of the 12. Half of the 12, stick on the square root of 2, right? Okay. That concludes page 1. Yes! Let's go on to page 2.